That's everything. Oh, no, it's not. One more thing. Okay, so we covered skin after, we covered the rats and spring break, we covered office people. Okay, y'all, this is my attendance list so far this semester. This is cohort 4. This is you guys.
What does that mean?
All the times that somebody's been absent.
Oh.
I know, and I'm not ripping ass, I swear, I know we've had a lot of illness, sickness, etc. This is a little much though for me. I know it's again because we have a large group. You guys need to start working on your makeup time now. Some of you maybe more than others, because what you don't want to happen is end of semester comes and you have 16 hours to make up and there's only 2 days left. I will not let you pass without the time made up, okay? So you guys can make up time at the hub over lunch break. You walk in, you type in on the little iPad that you're here, and it logs your time, okay? It is not a complicated process. You can do this over lunch. You can do it if you have a 30-minute break from Dr. P, go clock in for 20 minutes, right? Some of you guys, you know, that are like 20 minutes late here and there, go make that up so I can cross you off. Okay, I'll say also, I really, really hope that we're all over the sickness because it's going to get harder to miss time and be okay in class, right? You can imagine, again, missing just one day of anatomy can really make you miss a lot, right? Or one, day of farm or whatever it might be. So you really need to start making up your time. If you need a kind of a rundown, hey, Miss H, how much time do I have? That is always in my office, and I'll be more than happy to tell you, hey, you're working on 3.5 hours, start making it up, okay? It also makes it a lot easier for Dr. E and I to forgive you when you're late or absent, when you've made a good faith effort at making up your time so far. Okay, yes?
So do you have the times for all the classes or just
everything?
Okay.
Everything always. Maybe that's why the list is so long. Yep. Okay, I think we're good now. Let's do board stuff. Let's get into it. Let's get through it. Guys, I don't think we're going to get all the way through digestion today. We're going to see. We're not going to try to push, though, because we still have a lot of ground to cover. If we get there, awesome. If not, we do have still next week, of course, with nutrition to kind of recap. But I do want to last 20 minutes or so, 15 minutes today, to just give you a preview of exam stuff to start going back over, okay? Yes, digestion will be on this exam. Nutrition for next week will not be, okay? Okay, all right, let's do this thing. All right, so what is the structure that suspends my organs? The mesentery. And then the holding net thingy? Okay, very good, the omentum. And what we could do, guys, even if we wanted, is suspension from the dorsal wall. And do you remember the holding net is more the ventral surface, because it's holding it in on my belly, if that helps. And then what's the burp? Eructation. Eructation nation. And then one of my favorite words of all times is the sound for when your stomach is grumbling. We hear this a lot in our large animals as far as gut sounds go. Borborygmus. Missing a G. Damn it. YG. Borborygmus or borygmi. And this is something, especially in cattle. Horses, yeah, to a certain extent. YG. Yeah, sorry, I had it GY at first. Borborygmus. Listening to the gut sounds of a ruminant can be very helpful in determining overall health. Just how fast or how loud and gurgly is their stomach. If it's not at all, that's a dead cow probably. Or a dead and dying cow. Yes.
Is there a way to auscultate a cat if it's purring?
Yes, but you won't hear anything but his purring. Or alcohol his nose holes.
Jeez.
Sometimes I try to feed it
Brown.
You can actually push forwards other ways.
So that happens in clinic too, and that's a good thing when your cats are purring in clinic because that means they probably won't kill you. But you do, Al had mentioned it, if you can, you know, and some cats will flip out on this, but if you just turn your sink on, like in your bathroom and just like hold your cat and try to like walk up to it. Don't put the cat in the sink. Yeah, I mean, some of them are. But sometimes the sight of the water going is enough to stop them from purring. I don't put alcohol on their nares, but I will put alcohol maybe on my hands and as I'm holding their head to listen, you know, they can kind of sort of smell it and that usually will stop them too. Again, I only need it for like 10 seconds. Again, if I can't escape, I'm gonna feel pulses. That's always your go-to. If you cannot hear something, screw it, stop wasting your time and my time, feel up the pulses. That's why, again, it's so important you know how to do that. All right, so we have 4 parts of our large intestine. These are not, we already covered like our transcending or ascending, descending, and transcending. This is specifically different parts of the large intestine. So if we were to say where the small intestine meets the large intestine is the cecum. And then we have the colon itself, which is the bulk of our large intestine. Then what's next? The rectum. And then the, very good. Okay, so our 4 parts technically of our large intestine. We start at the cecum. This is again the connection point between the small intestine and the large intestine. The colon making up the biggest part where again water absorption is going to take place. The rectum is where the poop is waiting until it's time to come out, right? Yes.
Are you gonna label the large intestine different every time? Like, I didn't know what LI.
What do you mean?
It's like you do LI and then there's
The colon.
LG, intestine, and then
You should know them all. Because you could see them 50 different ways. That's just easy for me. All right, 4 chambers of our stomach, or excuse me, our ruminant stomach, not our stomach. Anybody know him? He is the glandular stomach that is similar to mine. Correct?
Is it the rumen?
The rumen! It's the biggest, yep, rumen and reticulum. And then what? Very good. So the biggest thing is knowing kind of what happens in each chamber. When we talk about our rumen and our reticulum, this is where microbial fermentation takes place. Okay, we don't really have microbial fermentation in our stomachs. Maybe a titch. But in cows, this is their main way to break stuff down, is using bacteria in their gut. And then the omasum is kind of like our large intestine, which means it does what? Absorbs water and some salts or nutrients. Minerals, let's just say minerals. Okay, so our rumen is truly the largest portion of this big stomach. Again, this is considered still one stomach with 4 distinct chambers. Okay, so we'll go through a little of that today. And then with horse digestion, 2 words that you need to know. Hindgut fermenters. And who did we say is pretty much the exact same as a horse? Rabbits. Very good. So rabbits also are hindgut fermenters. So that means instead of the fermentation happening early in the stomach, in the horse, it happens pretty much in their cecum, which is clear almost at the end of the hole, out. Okay, so it is quite a bit different. And again, it's because these guys eat different things, especially different from the small animal omnivore or carnivore. All right, what's the watery milkshake called? And how is it made? Raise your hand. I'm just waiting. So don't make an attempt to look it up or anything. Yes, Dom.
It's made by the body of the stomach when it does the.
Let me clarify. What is the process used to create the milkshake in the stomach?
Is that when it does the eggshell wraps with
Mm-hmm.
the
Yeah.
pepsin makes the change in the.
Yeah, you're not wrong there. But there's another specific piece, and this is how we are going to break things down in the stomach. This is how we're going to continue breaking it down in the small intestine. It's one word. Starts with an H.
I was going to say include surface area.
That's the Ruge that does that. Good job. Good guess, but no. Water breakdown.
Oh,
Maybe I just didn't ask the question right. I'll take blame for that. Hydrolysis is really a big part of the process. Yes, you guys are totally right with the chemicals and hormones and all that. We talked about that for sure. But we left off yesterday talking about in the stomach as we're moving into the small intestine, really a big part of making it really watery and milky is adding that water to help break things down. Yes, the chemicals are going to help with that, but the chemicals, guys, they're more there to break down specific parts. Whereas the hydrolysis is happening just all over. Okay, where again, pepsin is only doing what to what?
Making amino acids.
Breaking down protein. Okay, so pepsin, as awesome as he is, made by his whatever cells, does jack crap for everything else I eat. But hydrolysis will help to also break those other things down into their simple little structures to be absorbed. So this is a big one, guys. This is a big one. Maybe even go back through in your textbook and find where it talks about hydrolysis in your text. Okay? So that's where we're going to pick back up today, specifically. I'm going to pull up your spelling, though, first, so we can say our words for next week. I'll find it for you. I think I still have one more. Let me see. Oh, I think I already said this. It's hard for me to control myself sometimes. So we have, oh dang it, okay. We have a structure in our bodies that is vestigial, really. Doesn't really serve a big purpose for us. It's the equivalent of the cecum in animals. Sometimes you burst and you have to get it taken out. Your appendix. So the appendix is thought to be our leftover rudimentary vestigial cecum back from when we were plant eaters and only plant eaters. So when we were apes, right? What's that?
If you think apes are only plant eaters, you
Oh,
are
I
so
know nothing
mistaken.
about apes, so I will just stop myself right there. Primates, I think my note says primates, so me bad saying apes, especially in the presence of a food person. But our appendix really doesn't do anything for us. It's kind of just there for no reason. In dogs and cats, or really dogs as omnivores, they can still use their cecum, and their cecum can become quite inflamed, even though it's really not a big site of digestion in the small animal. Now in the horse, the cecum is everything to life, everything. And same with the rabbit too. And I go so far as to include the guinea pig in that. All right, so week 7 words. These are our nutrition words. So we have contractile, cytochrome,
Cytochrome,
monounsaturated,
monounsaturated,
glycolysis, phosphorylation, macromineral, transamination, osmoregulator, Krebs cycle, coenzyme. Sweet. Okay. All right. So we're gonna roll back into where we were. Like I said, I don't know that we'll finish today. We will see. I guess it kind of does. Sort of.
like, you know, when they come from the store.
Yeah.
Ooh, okay. So this is kind of where we left off yesterday with, we ended with the stomach, right? And getting us into the pylorus and ready to head into the small intestine. Now again, the small intestine is the one who is controlling how much the stomach empties and when, right? So it's the small intestine that's kind of in charge of continuing the process. We talked about our 2 big small intestine secretions. So just like the stomach has its own secretions, the small intestine does too. And these guys are actually the ones that are pretty much giving us chemical signals of yes, open the pylorus and send me the chyme. Or no, I'm not ready yet, hold up, okay? Like I said, I'm not too worried about the GIP. We'll talk about him a little bit further when we finally get to the small intestine. Okay, this again is where we have our 2 phases of chemical digestion. Yes, again, our enzymes that we've talked about so far, like pepsin or pepsinogen and all of those guys, yeah, they help break things down. We have to have hydrolysis as well. That's what really is gonna help make this super watery. I mean, again, keyword, watery milkshake. There's gotta be water involved, right? So our hydrolysis is adding water to break things down. This is dilution 101. Yes.
What if that's the digestion of the stomach? Are you going to want us to list the hormones? Or are you just wanting us to know the small intestine?
Why don't you ask that again after I've done exam review at the end of class today? Just say. I'm just saying. Okay. So hydrolysis happens in the lumen, which again is the big tube of the stomach, right? So again, we're adding water, mixing things up, making it break down. And then again, on a cellular level, okay, so again, monomer level. Okay, the burger has broken down into proteins and has broken down even further into our amino acids. Okay, it's helping with every part of that, both gross breakdown and very small, tiny cellular breakdowns. Yes.
Where is
The lumen, any lumen is a tube. It's an open tube. So when we're talking about here in the stomach, it's the hollow part of the stomach, right? Okay. The lumen is just an open tube. Catheters, when you place catheter, what the needle goes through is the lumen, okay? All right, and then I think we left off here as well, really basic breakdown of what we're trying to break down, right? So again, our carbohydrates are going to break down into our sugars and starches. Our proteins are going to break down into our amino acids. Our fats are going to break down into fatty acids and sometimes sugar. And then vitamins and minerals, pretty obvious, whatever they break down into. So just really basic, this is just a couple slides of what may seem like more nutrition stuff, but it's going to help just having a kind of basic understanding of the components as we get to how this actually is broken down and absorbed. Okay, and we're doing this for both the monogastric and the ruminant stomach, so just bear with it. And you probably know, again, a lot of this. So our carbs break down into sugars. Monosaccharides mean one sugar. Have you guys heard saccharide before? Yeah, okay, little yellow packets, great. Okay, so that's our sugars and starches. Okay, so starches made of repeating glucose monosaccharides, sugars also made of simple monosaccharides or multiples, which are disaccharides. How many sugars? Okay, very good, so you guys got that. Cellulose is a very complex carb. Cellulose is where a lot of our large animals, cows and horses, are going to get their energy from. But they have to do a lot more work to break down cellulose than we do. It's a lot harder of a process, which again, we will get to. And then proteins, we covered this yesterday on board stuff. So when we talk about a chain of more than 50 amino acids, it's a true protein. If it's less than that, it's just a peptide, okay? And you guys will have on your homework, if you haven't started yet, how do proteins appear or amino acids appear? It's like little pearls on a string, right? Making up a long chain, okay? And the longer the chain, obviously, the more it can do to be recycled or reused, right? Like we need proteins, but we also need a lot of different peptides, which will eventually build up into protein. Okay, again, with our fats, so lipids have a glycerol backbone with fatty acids involved. Fatty acids are good for us. They give us energy. This is actually the main source of energy with our large animals, is our fatty acids. Okay, so really just kind of basic. And then chemical digestion, we've talked about before with amylase. So amylase is going to break down our sugars and starches, right? So it starts from the second you put the saltine in your mouth, that saliva has amylase. It's going to continue to break down in the stomach and a small amount in the small intestine as well. Most of the time though, guys, when we get to the small intestine, the majority of breakdown has happened because the small intestine is ready to do what and what only? Just absorb stuff. But there is a small amount of breakdown in the very cranial portion of the small intestine. Do you guys remember which portion that's called? The duodenum. All right, and then protein digestion can't even start until we hit the stomach, right? So protein digestion doesn't really start in the saliva or in the mouth like we think of with carbs. Okay, that's mostly in the stomach. Again, small amount in the small intestine. You already know, again, our pepsinogen can only turn into pepsin in the stomach with the HCl. And this is kind of where we get into the large animal. And we're going to come back to some of that nutritional stuff once we kind of get through this. So this is what Keisha thinks looks like a turkey. Put it in your roasted pan. Get it ready for Thanksgiving. So the rumen here, again, you can see is the biggest part. Even part of this side is our rumen. The rumen takes up the entire left side of the animal. Okay, whether it be the little cow or goat or what have you. Okay, the rumen is the biggest chamber. So again, you can follow the esophagus. It's going to lead right into our rumen and a little bit of our reticulum here. Oftentimes, people will even combine these two chambers into one and just call it the reticulorumen. And that's okay. That's appropriate too. Okay, there's really not a big dividing wall between the rumen and the reticulum. Okay, so some people will keep them together. Yes?
What view is this? Like, is this from the right
This
side?
is from the right side. This is the left side of the animal, like I just said. Yep. So the four stomachs, again, your reticulum and rumen, what happens there?
Microbial formation.
Very good. The omasum, not somebody who just answered. Great. And then our abomasum is really our true stomach. It is considered glandular. Glandular means it secretes stuff, like chemical enzymes. Okay, so the abomasum is kind of like my stomach. It even kind of looks like my stomach a little bit, doesn't it? It's kind of got that shape. All right, and then again, we move into our duodenum from there, okay? We'll go kind of through each chamber here. We already talked about most of this. Again, the abomasum is just like mine. These guys have a lot of work to do to break down the cellulose, which is the main component of their diet. This is why they have to have that microbial fermentation happen before it even gets into the real stomach. We have to have, again, lots, hundreds, even thousands of bacteria starting to munch and break down the cellulose for us, so that when, as a cow, it gets to my abomasum, I can make sure it's completely broken down before sending it onto the small intestine, where I'm going to absorb all my nutrients. Okay, so rumen reticulum, very, very important for these guys. Again, it's really hard to break down cellulose. Oh, there you go, reindeer. I'll use reindeer as my next model. Right, so the four stomachs, the paunch is what we sometimes call the rumen. It is because it's just a big, like, fluffy bellow. The picture board we have out there with somebody's arm up in the cow's hole, that's in a ruminal fistula. Have you guys looked at that board yet? Okay, for those of you who did not answer, you're going with me on break. We're gonna go look at those GD pictures. You know what I'm talking about. So again, most of the left side, tons and tons of microorganisms, AKA bacteria, okay, that are there for a reason. You're there for the health of the animal. Yes, we do have some papillae and lots of rugae, tons of rugae, to again increase surface area to help break all of this stuff down. Don't really care that it divides into different pillars, but you'll see pictures of that as we get through. Okay, so the rumen, biggest, left side, bacterial fermentation. Boom, yes.
On this, okay, you might break that.
Yeah.
Oh, sorry. But is this little part also the rumen?
Exactly. And that's kind of what this is referring to. Yeah, the extra sacs. Yep. It's a big, big thing. And it is super fun to see the contractions happen in the cows that have those fistulas. It's pretty incredible. All right, and then we have the reticulum. No shock to you, I've taught you before that anything that's reticulated looks like a net, yes? Look at this. Holy heck. Okay, so we call this the honeycomb. That's kind of also what it looks like. With the reticulum again, microbial fermentation happening. Again, some people will even go so far as to just include it all together. Okay? Any of you guys like, it just slipped my tongue. You know what I'm talking about? What the hell? My mom makes it with pig's feet and I hate it.
Is it menudo?
Menudo, thank you. Oh my God, it was like zooming by my brain.
The honeycomb tribe?
Yes. Yeah. The stomach gland.
I've had it.
No, it's not. I love the hominy. Let's get down to the hominy. I do have a texture problem. Yeah, I do have a texture problem. My mom cuts hers really, really thin. My stepdad's Filipino, so that's why she makes it for him. Because I never had that in my life until. But it's actually a little cut for, yeah, what it is. All right, and then we have this really neat thing. Well, the baby cows might not think it's neat. Maybe they do, maybe they don't. So we have this thing called the esophageal groove. And in babies, what happens is that we bypass the rumen and the reticulum as a baby cow. As I'm suckling from my mama's udder, my milk is going straight to my omasum. Okay? So the esophageal groove leaves the esophagus with the omasum, because what happens in the omasum?
Absorbs water.
Absorbs water. What would happen if my milk from my mama cow went into my rumen or my reticulum?
Is it broken down to absorb nutrients?
It'd be broken down. It turned into rotted milk. What happens when you add bacteria to milk? It grows. It gets gross. It rots, right? I'm sorry?
How's cheese?
That's right. That is not what we want to happen to poor little baby cows, right? So they have an esophageal groove that links their esophagus to their omasum, so it just goes straight into the omasum, absorbs the water to a certain extent, and then goes on to continue absorbing the actual nutrients from the milk. If it doesn't close, again, madness. So this, it is cute, right? This is something, you know, you'll have all sorts of little moments like this of little things with cattle and horses when you get to large animal, because we've covered it once. Hopefully you'll be better prepped, okay? So again, milk goes directly to the omasum in these cases, these little babies. And eventually as they age, it closes, okay, when they are weaning. And then the omasum's really cool. It has all these pages. You can kind of see. These are like mega rugae, like rugae times 10, right? So again, the whole purpose is to have increased surface area for absorption. Okay, so it has all those little pages. Kind of looks weird. Now when you drive by the highway and you see the cow, I hope you think of the 4 chambers, what they look like inside themselves. Yes.
So if you were to stick your hand in it, is it more like
It'd be super soft.
really?
Yeah, it'd be super soft. When you stick your hand in the rumen, you are not feeling anything except for giant amounts of food stuff.
Do they close that off when people are poking it?
They have a cap that goes in. Yeah, they do have. But they have the fistula for their entire life once it's put in. So what happens is little baby cows, well, and it could be an adult cow actually, a cow that's not gaining weight, having heck of GI issues, just whatever the case might be, probably what is the problem is that they don't have enough good gut bacteria. So what they do is they take a healthy gut sample from a cow who we know is healthy as heck, take it out of her hole, feed it to the other cow. Now that cow has ingested all of that bacteria. And it's incredible. You guys will get to go in October and see this. Before they let you even put your hand up in it, they will take a sample, a ruminal sample, and they'll put it on a microscope for you guys. And I mean, you cannot find anything because there's so much movement. I mean, it is like with bugs, and that's the way it should be. But if you were to take a ruminal sample from the sick cow, there'd be like, so like not nearly enough.
Cow, and it's like the purpose of helping them.
Exactly. Yeah, there's 2 of them, copper and another metal name I can't remember. Yes.
When they put them on antibiotics, is that something that they have to think about?
Absolutely. Yep. And a lot of times with antibiotics, it's very specific to the route. And if we can go parenteral, which means we're not affecting their GI at all, that's the preference. Now, again, it's difficult with some meat cows to just be giving them injections up in their muscle every other day because now we're ruining their cuts of meat. But absolutely, and that's a huge part of large animal medicine. You guys will cover inappropriate treatments with antibiotics and other drugs too. Yes?
What's that stuff that you can give animals when they have diarrhea? I can't think of the name. It comes in a syringe. Move the thing down. Like,
Ponzeril.
I don't know what kind. Like prolactin, is that it, or is it a different kind?
Prolactin is a hormone to make me have milk in my boobs.
That's not what I'm thinking. I don't know.
I'm thinking like marquipase, Ponzeril, fenbendazole. A lot of those come in those.
Is that like stuff that helps?
You're probably thinking of something for like scours, like for baby calves. Ask Caitlin.
It's not like we give it to dogs
Mm-hmm.
and cats. It's pink. I know that. And there's like, I don't know.
You probably know more than me at this point. Ask Caitlin. Ask Caitlin. She might know right off the top. Okay, so omasum, water absorption, tons of pages for surface area. Okay? Sweet, and now we've got to the abomasum. So this again is just like meat. This is our monogastric equivalent in the ruminant, okay? Again, he's glandular. What does glandular mean? Start to break stuff down. Dang it. Why? Thank you for not being muted this time. We have renin that causes milk protein coagulation, and that just helps prolong the time that we have to really break those proteins down. The abomasum really isn't a storage compartment, though, like we say our stomach is, it just holds stuff. The abomasum is continuously pushing stuff on. There's a constant flow of ingesta into the abomasum. So a little bit different from the monogastric stomach, but quite similar. Okay, got our 4 chambers. Feel pretty good about them. Rumen and reticulum do what? Ferment with microbes, very good. The omasum and the abomasum, I would know he's glandular and equivalent to the monogastric. It's really all we need to know about these. Again, contractions in the reticular rumen are happening almost constantly. When you guys go to feel up the rumen at K-State, keep your feet back because she will burp out of that hole onto your shoes. If you want to do it, you can. You don't have to. I won't force you. And it does stink quite a bit. What they're kind of just showing you is that, again, the food that we're eating does not necessarily go through very quickly. Especially in the cow stomach, it's sitting there for days sometimes. So again, really make sure that we've broken it down well enough. What are we breaking down? What are the cows breaking down?
Cellulose.
Cellulose, very good. So the cellulose, again, takes forever. So it might actually be sitting there for a couple days before it actually is broken down well enough to move on into that abomasum and into the small intestine. You can see here too, you guys already knew, cows are very gassy creatures. That's why they must eructate, right? Or they will blow up. And there's quite a bit of gas as a byproduct of that microbial fermentation. Okay, so they're burping methane, farting methane.
Isn't that why
It is bad for the environment. I know. But yes, that's exactly true. For sure. Why don't we go ahead and take a break, guys? Come back at 11:20, I guess, and we'll go from there.
It's called probiotic.
I would never have even. No.
It's by Nutramax.
Yeah, it just like.
Well, and again, I have very limited. Okay, so again, looking at the big part of our rumen reticulum, where all the microbial fermentation happens. Again, just kind of showing when the food comes in. This is the fresh food. This is food that's still being mixed up from yesterday. Because again, that cellulose is just so difficult to break down to really get the nutrients out. So when we say cows chew their cud, this is the active rumination. So 4-step process here, they regurgitate their food from their stomach, they regurgitate it all the way up their esophagus, back into their mouth, they chew it up again, so re-insalivate, re-masticate, and then swallow it again. And this can happen quite a bit. Again, their body can tell how far more needs to be broken down by setting it up, putting it through that process again, sending it back down, okay? This is, again, the majority of their life is spent doing this. Fun if you're a cow, right? Super fun. Some birds, yeah, but it's not really quite for the same reason. Yeah, it's not really a matter of breaking their food down. Birds do have a additional structure that helps with breaking stuff down. That's called their crop. We'll cover that next year. Next semester. Yeah. All right, and then your eructation again is your burping, your belching, letting all that gas release. Again, methane is a big one, carbon dioxide, another crappy one that comes out as part of this process. And it's kind of normal, but yes, definitely a big concern for the environment. Again, if they don't burp it out, they can bloat, and that can be a fatal condition. Yeah, there you go. Gotta get it out. Better off than in, right? That's what Shrek says.
I was just thinking that.
That's right. That's right. So just like us, to a certain extent, our nerves, our nervous system controls the activity in our digestive tract. And same thing here with our ruminants. They also, again, have that just underlying involuntary control. Okay. So in the reticulorumen, again, tons and tons of microbes. So we have bacteria, different protozoans, and some fungi creatures as well. All of them have a specific role to play with breaking that cellulose down. Okay, so tons and tons of microbes. Again, it is a very structured system. It's not just a big overflow of bacteria. This, again, is bacteria that is meant to be in them. And again, this is something after birth, their system starts to develop quite quickly. And then again, oxygen, of course, as we eat, we often are ingesting extra oxygen, making us have a little extra gas to burp up to. No different. Right, the ruminant's diet again, mostly grasses, which are complete complex carbs. So again, we're having to break down cellulose, hemicellulose, and then pectin, which is a form of sugar or saccharide. Sometimes they'll eat grains, which are more non-structured or they're not as complex of carbs, a grain diet. Grains, again, are more starches and sugars. So they are, again, going to get the basic nutrients at the end of the day. They're just getting it from a slightly different source. Again, microorganisms within the reticulorumen, they are good because they're helping us break stuff down, but they actually will eat some of the nutrients before my cow body is able to actually use them. And that's kind of one of those, we have to let them survive by eating some of our nutrients, because if they didn't, all of our gut bacteria would die off, and then we would not be able to process anything. Okay, so sometimes the bacteria steal from us a little bit. We have to allow it. Now, in cases where the cow is maybe not eating as much protein or isn't getting as much protein as they need, the cow can actually digest some of the microorganisms, because bacteria also have protein. So they can actually eat them for their protein source. It's kind of cool, right? Again, the body can kind of tell, what is it getting? What does it need? Do any of you guys like just go to your fridge and eat like 3 slices of cheese?
Yeah.
Oh, hell yes I do. I fold it in half and make shapes out of it.
No.
Oh, the sliced cheese, my mom
Yes.
does that. No, you get the cheddar.
So guys, I don't even care. I will go open my bag of shredded cheese and sit there and have like 3
Yes.
Oh, no, not just straight up cheese.
Oh my God. Okay. So again, when those things happen is because obviously I haven't been eating enough cheese. I'm craving it, right? I guess a similar thing would be you go to the fridge and you just drink like a gallon of water at once because your body is telling you you've got to, right? So again, our bodies know what we need, what we're lacking. And in this case, again, they can actually use their microorganisms as a source of nutrients as well, which is kind of cool. Okay. Guess how we break down carbs here? Hydrolysis. Again, a very, very big process to know. What is hydrolysis? Adding water to help break stuff down. Again, why it's so crucial that our water intake is where it needs to be. And the same with our cows too, or large animals. And then again, with starches and soluble sugars, which is what the carbs eventually break down into, we continue to break it down with hydrolysis. Okay, it's again a step-by-step process. So a gross, big breakdown, and then tiny, small, cellular breakdown. Okay, again, we'll get our saccharides out. Saccharides, again, can be actually transferred or turned into our fatty acids, which I said earlier and again here, fatty acids are a big source of energy for the ruminant. Again, are they eating fat? Does a cow go eat a piece of cheese? Of course not, right? Of course not. But lipids are a very important piece of energy. How are they getting that? From our fatty acids. Okay, just because they're a cow doesn't mean they don't need lipids. Okay. Again, lipid digestion, and this is something that we'll see in small animals too. So triglycerides, glycolipids, what is this a mix of? Sugar and fats, right? Sugar and fats, very good. And again, those are the two big energy sources, sugars and fats. Yes, they do contribute to a very small portion of their diet, but still very important that they have some kind of lipid intake. Don't really care about the rest. Again, with fermentation and breaking stuff down in relation to protein, this is similar to what we've kind of talked about before. Proteins are going to break down into our amino acids. The amino acids is what we have to get to break down into those building blocks that can be used to recycle. Especially in the cow, protein and amino acid breakdown, super, super important. Why? It goes into the meat. That's how they get big and fat, and I get the big steaks, right? So very important for them. Okay, I don't really think we need to go any more into depth on that. And then glucose production. So again, do cows eat ice cream cones to get their sugar intake? Of course not. But they are getting, again, those saccharides from that cellulose, from those complex carbs. They do have a way, and we actually have this capability as well. So gluconeogenesis, let's break that word down. Gluco is sugar. We know genesis is the beginning. Neo is new, exactly. So sugar, new beginning, creating new sugars, right? And this is something that the liver can actually do for us. So this happens in small animals and cows and large animals. Where if for some reason we don't have enough carbs coming in, we can actually break down and build up new sugars. For what reason? Energy, exactly. That's why we want sugar in our diet. It's for energy. Okay. Don't worry, we'll come back and cover gluconeogenesis when we get to the small animal liver. We haven't even got to a lot of the other digestive organs yet. We're still in the stomach. Still in the stomach here. Oh my God, we made it to the small intestine, finally. All right, so small intestine we covered a little bit yesterday. You remember your three parts, the duodenum, the jejunum, and the ileum. So the duodenum is the part that comes off of the stomach. The jejunum is the longest portion. So most of the squiggly that we see. And then the ileum, remember again, he's similar to the ileum in our pelvis, but we want to make sure we spell him right. He's the part that's going to connect with the large intestine, or the cecum. Jejunum is the longest. Everybody say duodenum.
Duodenum.
Jejunum.
Jejunum.
Ileum.
Ileum.
Very good. Okay, so the small intestine, again, very important. It's going to take the chyme away from the stomach. It's going to absorb all the nutrients along the way and turn it over to the large intestine to make into a piece of poop once all the once all the nutrients have been absorbed. Look at that liver, it's huge.
Huge.
We'll talk about him here in a bit. I think I pretty much already covered most of this. So again, suspended from the body wall by the mesentery, keeps all the tubes kind of in place, hanging in a nice fashion. Again, the duodenum receives the chyme through the pyloric sphincter. We do actually have a lot of action still happening in the duodenum, though it's relatively short. Again, the jejunum is the longest section. Most of the absorption and digestion is going to be happening here. Makes sense because, again, it's the longest section. And then the ileum empties into the large intestine, again, at the horse, at the cecum, the colon in the dogs and cats, and the cecum and colon in ruminants and pigs. As long as you know that the ileum is the last part of the small intestine that leads to the large intestine, you will be fine. Okay. The Peyer's patches we'll talk about a lot more when we get to the immune system. We have lots of immune patches like these all through our GI system. It's helping to keep us nice and healthy. Okay, so 3 parts of the small intestine. You guys feel okay with those?
Yes.
Yes.
Sure. Sure. Make sure you know them in order also. Okay. Everybody good if I go? Okay. So the small intestines have tons and tons of loops. We've kind of already covered that, right? It's like one big squiggly tube full of twists and turns. We have within the small intestine lumen, so again, the opening of that big twisty turny tube, we have these folds. And again, the small intestine, just like everything else we've talked about so far, has those 4 layers: mucosa, submucosa, muscle, and serosa. Within the mucosal lining, we have these plications, or these folds. What has so far have folds been used for? Surface area, increasing surface area. So that's why they're here as well. We also have these villi and microvilli, which are tiny little fingers. I think a couple days ago I said they're kind of like cilia, but they're not hair. They're more like these fingers that help to absorb. Again, we have what's called the brush border, which is where we have absorption of the nutrients taking place. So kind of what you're looking at, all the little villi is kind of like little fingers. And then we have these microvilli here. That makes it so, if we just have just one big structure, that's only so much surface area. But when we add all these tiny little lines to the edge, to what we call the brush border, it actually increases the amount of surface area without making the tube longer than it already is, right? And within that, again, we have absorption of nutrients taking place. Where then do the absorbed nutrients go? In the bloodstream, or maybe in the lymph stream. Okay, so this is the site of absorption in the small intestine. The lacteals, this is what our lymph is. So the lymph is the white structure. Obviously our red and blue are veins, or vessels. Okay, so the lacteals, again, carry absorbed lipids and other fat-soluble substances to the vena cava. It's going to go through cardiac circulation, become nice and fresh, and be sent out to the whole body. Okay, whatever part of my body needs that freshly recovered amino acid is going to get it through the bloodstream. Okay, your body's going to say, hey, send me that amino acid. I'm up in here in the bladder. I need to repair myself because you just poked me in my bladder. Okay, so this is how once our nutrients are broken down tiny, tiny, tiny into their most smallest, simplest cellular structure, they can be absorbed into our bloodstream. Again, they'll be carried to the heart and then eventually throughout the systemic circulation, which is the whole body so the body can determine what's needed where. Okay? Yes, our liver is a big site of manufacturing. I like to call him the recycling warehouse. And some of these nutrients will just go straight to the liver to sit there and wait in storage until they're ready to be built. Okay? That's a really simple process. Do you feel okay with that? Okay. So your homework for the test needs in this will cover a lot of the absorption, okay? The big thing I think really is just, again, understanding that surface area. Okay, cool. And then we're back to the chemicals of the small intestine. So we barely introduced ourselves to secretin and cholecystokinin yesterday. So here we are back with these guys. So cholecystokinin, his job is to stop the stomach from pumping. He's going to inhibit the gastric motility and emptying, which means he's saying, stop, bro, I am not ready yet. You can't send me your chyme, I'm not ready. He also can help with buffering what comes out of the stomach. The chyme in the stomach is relatively acidic, yes? The duodenum, when it receives that acidic milkshake, needs to tone it down a little bit. Okay, so the cholecystokinin can actually increase bicarb and some of our pancreatic enzymes, which we've yet to cover, so that when the food or the chyme gets to the duodenum, it doesn't burn through it because it's so dang acidic. Secretin, on the other hand, is going to decrease that acidic production. Again, these guys in the small intestine, these two chemicals are pretty much controlling the actions of the stomach. Because who's in charge at the end of the day? The small intestine. He's in charge. Okay, so he can tone down the acidity. He can increase some of our other enzymes, again, from the pancreas. Okay, that's really as deep as you need to go with these guys. Okay, they're either going to slow down or stop the stomach from emptying and buffer out the acidic content of that milkshake.
Does the CCK have anything to do with the gallbladder at all?
We will get there. We will get there. No, sort of, kind of, in terms of, and this is like, this says, stimulus for cholecystokinin being made is a high-fatty diet. That's where the bile will come in from the gallbladder. Sort of, kind of. But you're thinking chole. Very good. Yeah, very good. All right, then we get to the pancreas. Oh my gosh, you guys, the pancreas. He is one of the craziest organs. Now, we're going to learn about him, but we did not label him in our little drawing because, again, it's not common for you to be able to palpate the pancreas unless it is extremely inflamed, and even then you're not palpating it because the dog will bite you first because it hurts that bad. The pancreas is really important because it has two different roles in the body, two extremely important roles in the body. So we have the endocrine function. Endocrine means hormone, right? So he produces for us insulin, probably one of the most important hormones in our world. And then we have the exocrine function. The exocrine function is digestive, okay? So he has digestive enzymes that he squirts in to the small intestine to help continue that breakdown process. The pancreas, as you can see, is kind of this weird bubbly thing that hangs off the backside of our stomach there. And you'll note right in here, this is where we'll have our gallbladder entrant point as well into our small intestine. So he runs the length of the stomach and the first part of our small intestine there. Okay, pancreas is really cool. So again, with the endocrine portion, he's got insulin and glucagon. pretty important hormones. So insulin in our beta cells and our alpha cells produces glucagon. But what really sucks about the pancreas is that God took all these cells, mixed them up like this, and went into the organ. So when we have pancreatic tumors, cancers, disease, you can't just remove a chunk of it. It's not like liver cancer where we can remove a liver lobe and the dog can generally do okay. The pancreas is one of those very sensitive organs. Alex Trebek should be dead. I don't want to say it that way. He hasn't yet. And it's surprising how long he's lasted. That's the Jeopardy guy. So you guys remember Patrick Swayze?
Yeah.
Thank God. How quickly he declined. Yeah, how quickly he declined. Steve Jobs had pancreatic cancer. And they get very sick very quickly. And there's not a lot of treatment options. Now, in our world, fortunately, a lot of dogs don't get pancreatic cancer, but they do get diabetes. They do get exocrine pancreatic insufficiency. They have all sorts of problems related to their pancreas. And then again, we have the exocrine portion. This is digestion, okay? You do need to know this. So hormone, digestion. So with the digestion, we have the pancreatic duct that leads from the pancreas into the small intestine. This is where he's going to, again, put some of his digestive juices into the small intestine to help break things down. Again, one of those big things, chemical-wise, is the bicarb. Why do we need bicarb in the small intestine? Say it. No? To regulate the acid that just came out of the stomach. Okay? So in the small intestine, why do we need bicarb? To regulate the pH. Okay? Because my small intestine can't take that 2.0 pH. My stomach could, but I need to buffer it out. And that's exactly what the pancreas enzymes will help to do. Just like when we were talking about anticipation of eating, it makes you salivate, it makes your gastrin start pumping in your stomach. We also have the pancreas involved in that anticipation stage as well. And he, again, on his side, in the small intestine side, can start getting prepped down there. So again, as soon as that food hits your stomach, the process of breakdown occurs. As soon as it's ready to leave the pylorus, the small intestine's ready for it. Hit me up, bro, I'm ready. Okay? So again, the small intestine, very important structure. And up till now, we've just added the pancreas as a way to help the small intestine be also powerful. Okay? So endocrine, exocrine, very important. You guys have heard pancreatitis? So inflammation of the pancreas. So this is something that can happen as a sequela to just about any other disease process, something secondary to another disease process. But it's super common when animals eat really high fat meals that they can develop pancreatitis. Now schnauzers can just look at a burger and get pancreatitis. I shit you not. It really is important, you know, when we, well, how many of you guys feed your dogs human food? Come on.
I have big dogs.
Good.
She'll like climb, she'll look
So one of the big reasons to tell our clients not to feed any human food at all is, again, you know, one potato chip to a dog of Chewy size, that's a lot of fat. And that could, in a potential, trigger pancreatitis in her because she's so little and I just gave her 3,000 calories of potato chips, right? When they ingest, it usually is one of those things they call Black Friday as Pancreatitis Friday because all the people throw their turkeys away in the trash can and then the dog eats the entire turkey body, which is mostly fat at that point and bones. And it is a very painful condition for animals, and you can almost tell by looking at them that they have pancreatitis, by how painful they appear. What were you going to add, Rose?
that true in cats too?
Cats can definitely get pancreatitis, absolutely, with high-fat meals for sure. Most cats don't seem as, I don't want to say as susceptible, they don't seem as environmentally challenged because a lot of people aren't giving their cat human food. Though when I eat that shred and I drop a piece on the floor, Milky comes running, a little crackhead for cheese.
What about vegetables?
Vegetables are totally fine because they're not high in fats.
Yeah, like,
So like with my
In other
cat,
words, human
I
food
don't
is human
feed
food.
her like it's my father-in-law that does it, that feeds her, but it's mostly meat.
So like cooked hamburger should be drained and rinsed.
Okay.
I would say that about any meats. I would drain it and rinse it to get all the extra grease off. That is one of the most common when we find these random pancreatitis cases. What do you feed your animal? Oh, I cook him baked chicken every night with whatever. And it's,
Boiled chicken.
yeah, you just don't feed human food. That's just where I'm going to start next week's lecture with right now. Yes, Merce.
We had a client that would give their dog marshmallows.
What the heck is wrong with you?
I bet that was good.
Because she wasn't
We
feeling well.
Yeah.
Regular marshmallows.
Um,
Very unspicy.
yeah. I mean, God bless them. They
We had a
just
dog,
do what they
the
do.
only way they could get to take pills was spray butter.
Yeah, there you go. And that's,
What are you?
yeah, you hope for, 5 days, 7 days that they're on the drug. It's not going to affect them too bad. Yes.
It's a case from a long time ago, but it was a Pelham tick that ate a whole hand. He got pancreatitis. But I can't remember the why, but they did put him on insulin. Can they become diabetic from pancreatitis?
The reason they probably did insulin treatment then was a long-term post-treatment insulin as well, because generally the two are unrelated. But in the terms of severe pancreatitis, the pancreas is so freaking blown up right now. It can't even do its normal job. It's like stuck in froze mode. So it can't kick out that insulin to bring that blood sugar down. It can't produce the glucagon in the case of bringing the blood sugar up. And then also, it's not going to be producing your digestive enzymes, which means that usually that dog's not eating for a couple days until we can get the inflammation reduced. So chances are he had high blood sugar at that point, and they were just regulating it during the course of treatment.
So is that something that you can, I don't remember the entire outcome, but I just remember they put him on insulin. So is that something?
Possibly. Was he already obese?
Yeah. He was a tummy puzzle.
There you have it. So yeah, that's likely for sure, definitely. All right, so we've covered endocrine, exocrine. The pancreas, you guys are freaking out, all the different enzymes of the pancreas, right? So we have our trypsinogen, chemocitrinolactone, prolactase, procarboxypeptidase A and B. Don't care, I really don't. I'm not gonna ask you any of these big ones. The big things that you do need to know are the top four. So these are pretty basic. When we say we have four main substances in the body to break down, fat, sugars, protein, and nucleic acids, that's what we have here. So lipase breaks down. Okay, so fats, amylase breaks down, starches, which are sugars and starches. Nuclease breaks down the nucleic acids, and protease breaks down our proteins. What does the ASE mean? Enzymes, which mean they're gonna break stuff down. Okay, again, going back to cholecystokinin in the small intestine, it's cholecystokinin in the small intestine in control that says, hey, pancreas, I need some of your juice. Yeah. And again, the small intestine is pretty much the boss, the whole big process. Okay, just know that the pancreas produces these digestive enzymes. I'm not going to ask you the big specific guys, okay? Don't care.
I'm sorry, what did you say? Nuclease
Breaks down nucleic acids.
So is that part of the amino acids?
No, this is more like DNA structure. So here's the thing, guys. Nucleic acids are proteins. Proteins are proteins. Enzymes are proteins. See how important proteins are? Very. I mean, they really are the structure for almost everything in our body. A lot of our hormones are actually considered proteins just because of their molecular structure of being built as a chain of 50 amino acids, 50 plus amino acids. I don't know if that made it worse or not.
Well, aren't the amino acids like codons? I don't know. Like the 3 codons, and then that makes an amino acid. You know what I'm talking about?
Wait a minute, we'll get there with the actual structure, because we will break it down next week for an ammonia group, the co or co carboxyl group, and then there's always the R that makes it its own. I think just wait for it. Yes, Sharon.
What does the amylase group do?
Starches, which equal sugars. Sugars and starches are always together, and amylase breaks that down.
We can even say carbs.
You can say carbs, sure. But I want you to know, what does carbs mean? Sugars and starches. And again, breaking that down into saccharides. Good, 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 you guys. Oh my gosh! We got through the small intestine and the pinky. The pink. Yeah, that's one of those things you always say an animal has pancreatitis. Stupid. That's stupid. All right, so the liver, the bile duct, and the gallbladder. These 3 structures kind of go hand in hand. The liver produces the bile and stores it in the gallbladder. The bile duct is how we get it out of the gallbladder into our small intestine, because again, the small intestine runs life, right? All right, so the liver is considered the largest digestive organ in the body. Again, no food ever goes there, right? The burger never touches the liver. It's only the breakdown molecules of the burger that eventually go through the bloodstream and end up in the liver. Again, the liver is what I always call the recycling center or a manufacturing warehouse or something. This is where a lot of our spare parts, our spare amino acids, our spare peptides will end up. And then again, when the body needs it, the liver will release and send through the bloodstream where it needs to go. Yes?
Chris told us yesterday that it was like the blood bank, or was that something else?
That's the spleen.
Oh, spleen,
Yeah.
sorry. I got that.
That is the spleen. So the liver is involved in a lot of coag factors, let's just say it like that. So the liver does actually make all the proteins that help my blood clot. So there is something to do with blood, but yeah, I wouldn't call them the bank necessarily. Again, the liver does a ton. The liver is super, super, super important for digestion, for just life, just for maintaining life and form. Okay. So functions of the liver, again, can secrete essential substances that will help with the digestion and absorption. It synthesizes different nutrients and then also regulates their release into the blood or into the body. So again, he's kind of, in charge of shipping and receiving to a certain extent. It's like a FedEx center. Okay. The liver also excretes and metabolizes toxic substances. You guys have learned yet in PharmCo, the liver always metabolizes. Small amount of excretion. I always say big excretion takes place in the kidneys. But the liver, again, very important here. Very important. Blood coag factors, cholesterol, and plasma proteins are, again, other things that the liver is in charge of making. So again, important to digestion, but then also important just to like big everyday life. Does anybody like eating liver? No. My dad does.
Liver nuggets.
He does. I will eat just about any other organ. I'm sorry, I don't know why.
Kidneys stink.
Yeah.
Like what?
So bull testicles are pretty good.
Oh yeah.
I really are. I do like gizzards. I will not really, I guess it depends how much I drank, if I'll turn down chicken livers or not. Because that's usually, oh no, no! That's usually what I eat when I'm drinking is gizzards. Thank you, thank the Lord above. Chicken livers are okay, but yeah, I'm not really a liver. Because chicken livers don't taste like the irony bloody beef liver does.
What's the other word for animals?
That's it, Rocky Mountain oysters, yeah. One of my friends in Texas had just posted, I hated her, I was like, God, I wish she made my dinner, because she had like shrimp and cheesy grits. She had the biggest freaking bullfrog legs.
Oh, wow.
Oh yeah, if you've not had frog, frog's really good. Well, she had posted this picture and she'd said, you know, don't these look like Ken legs? Like Ken Barbie doll legs?
my
Because they were that big. They were medium. Yeah. It's like, send some of those up to me. Liver, again, very important. Very important. But we don't need to eat it. So we have two surfaces of the liver. The diaphragmatic surface, again, the liver is the most cranial. It sits right up behind the diaphragm. And then the other side is the visceral, so it's facing the stomach and all the rest of the organs. Again, going back to that one picture, the liver is huge. I don't care about the falciform ligament, don't care. Our liver is lobed in most mammalian species, strategically in place to process blood that's leaving the GI tract before it goes up into the heart, gets circulated there. So again, it keeps toxic substances from entering the body. It can filter that out first. Okay. The triad, I don't really care about that either, just an area that they reference. This is more important when you get to like x-ray and ultrasound. Not terribly important though for you guys. It's just the entry point for our vessels and then our duct. Don't really care too much about the sinusoids. I guess it's worth noting the liver, again, as it does help to filter the blood, does have these large pockets or sinuses where we can have pooled blood as it's waiting to be filtered. And then we also have these specialized cells from our immune system that hang out in the liver to help catch any bad guy that's trying to get through as well as part of that filtration process. Hepato is the word for liver, if we haven't covered that yet. Hepatocytes are then obviously liver cells. Yes? So our hepatocytes hang out in there as well. They can enter the bloodstream as needed. And then bile, again, bile is made in the liver by our liver cells, and they can control the release of bile as needed. So why do we need bile? For what purpose? What does it help break down? Say it? Fats, exactly. So there are some animals that do not have a bile duct nor a gallbladder. Who would they be? Say it? Okay, very good, because they're not eating any type of fat. They're only eating plants. So the horse, the rabbit, the cattle, right? These guys don't need that gallbladder. There's no purpose. They don't need it. They don't have it. Okay?
Is there an instance where they accidentally delete me? Is there something that happened?
No.
Deer eat chick legs quite frequently for
They
their calcium.
seem fine.
Gotcha.
So just to show you kind of what it looks like, so the big ass liver, right? Huge. Right? You can see your stomach here. The spleen again kind of hanging out next to the stomach there on the left side. The pancreas again kind of just looping along the back of the stomach and small intestine. And then you have the pancreatic duct that enters the small intestine from the pancreas. And then our bile duct takes the bile from the gallbladder also into the small intestine. So just kind of showing sort of what it looks like. When you do a necropsy, that gallbladder will be that green.
It's really cool.
It is. Okay, so you'll see that sooner or later. So again, the gallbladder stores the bile until it is needed, until it gets the message that, oh gosh, we've got a big fatty meal, send me some bile. So I can write it down, right? So again, it provides a way for the liver to excrete waste. Even when the animal is not eating, we can still have some of that flush out effect from the bile in the gallbladder. What is bile made of? Bile salts, phospholipids, cholesterol, and different pigments that give it that what color? Yellow. When you spit up bile, it's not usually green, right? Have you guys seen a dog vomit bile before?
Yes.
As far as the enterohepatic circulation, what does that mean? So small intestine and liver. Entero is small intestine. If you didn't know that, you need to write that down. That was Tuesday board stuff. Enterohepatic then means small intestine and liver. So it's the circulation between these two structures. And this is, again, how we have the bile traveling kind of back and forth from the liver to the small intestine. It doesn't really go back to the liver. So this kind of is just talking about how bile salts, once they are actually delivered to the small intestine, it helps break down the fat. We recycle. The body recycles everything. So once the bile has come down, broken down the fat, did its job, the bile salts are going to be recycled back to the liver. Okay, so not the bile itself, but just one of the ingredients that helps to make up the bile. This is actually one of the big ways that we test liver function, is through bile salt production. Okay, so we can actually test this in the blood. I'm not going to ask any big specifics, it's just worth noting. Again, the body loves to recycle what is not waste. That's how we keep alive. Okay, that's all we care about here.
I'm sorry, I missed what part you said.
Enterohepatic. Entero is the root word for small intestine. And then hepato is liver. And then ic is pertaining to. So this is circulation pertaining to the small intestine and the liver. Again, pretty much the same thing I kind of said as far as the recycling process. Bile salts come out. The liver can actually influence how much it sends out. Again, depending on the message it's getting from the small intestine of, oh my gosh, this is really fatty. I need some extra help. Send me more, etc. Don't care. Very good. Yeah, this is kind of important, I guess. You guys have maybe talked about this maybe a little bit in ClinPath too. Talked hemoglobin and bilirubin, some of that stuff. So heme is our blood pigment. Did we know that? Heme is our iron, which pigments our blood. Okay, if you didn't know that, that's good to know. So heme is converted to free or unconjugated bilirubin. Bilirubin is one of these factors that we talk about from the liver. So free bilirubin joins with another substance in the liver to create conjugated bilirubin. All that means, you know what conjugated means?
Join.
Yeah, like conjugal sex. When you go to jail to have sex with your person.
What? What?
So you're conjugated, you're coming together, right? Okay, too far. So conjugated bilirubin just means that it's heme plus something, okay? And now we've got bilirubin. So bilirubin is released into the bile. As part of that, it's going to eventually get into the small intestine. What happens then is we're pretty much just breaking it down. So bacterial enzymes are going to help break it down into our urobilinogen. Urobilin, stercobilin, And even urobilinogen is what gives pigment to your poop. You did not know? There you have it. Again, most of this is going to be excreted as waste because it's just a waste paint at this point, right? The rest that doesn't get excreted, is again, the body's only going to get rid of what it doesn't need. The rest is just going to get recycled back up into the liver. Okay. Really quite basic breakdown of the bile. Again, it's pigmented, so it makes sense that it gives color to other things. Don't care. When we have increased bilirubin in the blood, because it did not get excreted, we turn yellow. Just like the highlighter, right? Because that's what we're talking about, is our bile pigment, right? Okay, so you guys have heard about jaundice before. What's the other word for it? Icteric, sure. So again, we can have all sorts of different issues with our liver, either producing way too much, not recycling it appropriately, which means excreting the waste amount. And if we're not doing that right and it's not getting pooped out, we turn yellow. Right? So when we see an animal who's jaundiced, we know immediately it's something to do with their liver function and something in the process of the production of bile and the inability of the body to excrete the waste. Right? Isn't that neat?
Yes.
Only so neat, I know. Why don't we stop here? Somebody write 104 for me for Tuesday. We only have maybe 15 more slides, but I do want to have just a tiny bit of time to go over exam stuff with you guys for next week, so you can have all weekend to, again, review chapters, review board stuff, all of that jazz. So we'll come back and finish up the very last bit on Tuesday, and that will get us into nutrition as well. I know that was a lot, guys. Good job. That was a good 50-some slides for sure. All